Ever heard of dark plasma? It sounds like something straight out of a sci-fi blockbuster, but it's a real concept that physicists are exploring right at the frontier of cosmology. Let's dive into what this mysterious substance might be, how it could work, and why scientists are so intrigued by it. First, let's break down the term. In mainstream theoretical physics, dark plasma isn't just a cool name. It describes a hypothetical state of dark matter. We know that regular plasma is an ionized gas, a hot soup of charged particles like electrons and ions, all zipping around and interacting through electromagnetism, the force carried by photons. Well, dark plasma is theorized to be the dark matter equivalent of this. Imagine a hidden, parallel version of plasma. Instead of electrons and protons, you have dark electrons and dark protons. And instead of interacting via regular photons, they communicate through a dark photon and a dark electromagnetic force. So, you do have a whole hidden sector of matter that behaves just like the plasma we see in our sun and in lightning bolts, but it would be completely invisible to us. This dark plasma could form its own structures, maybe even dark atoms, dark stars, or entire dark galaxies, all held together by their own secret forces. So why are scientists even considering this wild idea? It's because our standard model of dark matter, known as cold dark matter or CDM, has a few nagging problems. The CDM model predicts that dark matter is completely cold, collisionless, and only interacts through gravity. But when we look at certain galaxies, especially small dwarf galaxies, their structures don't quite match the predictions. There are discrepancies in how stars orbit the galactic center, and other puzzles that suggest dark matter might not be so simple. This is where dark plasma comes in. What if dark matter isn't completely aloof? What if it can interact with itself through this hidden dark electromagnetism? If dark matter particles can push and pull on each other, it could solve some of these cosmic mysteries. It would mean dark matter isn't perfectly cold, but has its own internal dynamics, its own physics. This self-interacting dark matter could clump together differently, forming galactic cores that better match what our telescopes observe. It could even affect how galaxies merge and evolve over billions of years. Let's visualize the parallel. In our world, plasma is governed by electromagnetism, carried by photons. In the dark sector, dark plasma would be governed by a dark electromagnetic force, carried by dark photons, while our plasma radiates light and heat that we can see and feel. Dark plasma would radiate dark light or dark radiation, energy that our instruments can't detect directly. The only way we could ever know it as there is through its gravitational pull on the normal matter we can see, or perhaps through extremely rare, subtle interactions between their world and ours. Now, you might be thinking, this is all theory, but is there any proof? As of now, there's no direct detection of dark plasma or dark photons, but that hasn't stopped scientists from looking. Huge, sensitive experiments buried deep underground, like XENO 1T and LUX-ZEPLIN, are designed to catch the faintest whisper of a dark matter particle bumping into a regular atom. At the same time, particle accelerators like those at CERN are searching for the dark photon itself, the messenger particle that would make this whole dark plasma idea possible. Cosmologists are also running complex simulations to see what a universe with dark plasma would look like, and some models suggest it could form massive, invisible dark disks within galaxies. It's also worth noting that outside of mainstream physics, the term dark plasma is sometimes used in more metaphysical or esoteric circles to describe a kind of life force energy or a higher dimensional field. While that's an interesting thought, it's important to separate it from the scientific hypothesis, which is grounded in mathematics and testable predictions. So, why does this matter? Pursuing the idea of dark plasma, even if it remains unproven, is crucial. It pushes the boundaries of what we know. If it's real, it could be the key to finally understanding the true nature of dark matter, which makes up about 27% of our universe. It could explain why dark matter behaves the way it does and might even offer clues that connect it to another cosmic mystery, dark energy. By searching for a hidden force that mirrors our own electromagnetism, we're not just looking for new particles, we're exploring the fundamental rules that might govern a vast, unseen part of our reality. If you enjoyed this deep dive, don't forget to hit the like and subscribe to see more. Thank you so much for watching. See you in the next video.